Welcome back, everyone. And today we're going to start dealing with some more animations. And to facilitate animations, we're going to use tweening and easing. And what I have up on the screen is Robert Penner's Programming Macromedia Flash and MX book. This book came out back in like 2002. And he's the guy, this guy up here, that essentially created tweening and easing functions. It was his easing functions that are easing equations that really kind of just I guess revolutionized things. Because I know when this book came out, I was doing a little bit of Flash and I was doing a lot of DHTML. That's something that probably doesn't even technically is called anymore. Now it's called like HTML5. But I remember I would use his equations and port them over into JavaScript and actually animate things on the web page. And also used easing equations in Flash. The easing functions, or I should say the easing equations, were so popular that Macromedia, the owner of Flash, or the creators of Flash, actually licensed these equations and made it officially part of the ActionScript library. So and every animating library worth its salt to this very day uses some form of his original functions. Nowadays they use an optimized version because originally his equations would require a start and end and time, and that would kind of automatically interpolate those two values. The more optimized versions nowadays don't interpolate the values for you. You throw in a time and it gives you a new time, and then you use that to interpolate how you want it to interpolate it. So that's how the equations exist now. But Robert Penner is the ones who actually created easing and tweening. And what is tween? Well, easing. What is easing? A couple of videos ago, we did a parabolic curve in a shader to kind of ease change, so it's not so linear. And one of his equations is if you remember correctly, it's y equals x squared. And that is the quadratic. It's this curve. And here's a site, easing.net, that actually shows you all of his equations. And they're actually, his equations are also part of CSS nowadays. Like I said, any animation library worth its salt has these easing equations in it. So this site shows you how it all animates. So if you think about this as a start of 0, and this is a start of 1, when you put in, let's say, a value of somewhere between, this is the value you get back out. So a quadratic, a parabolic curve is a quadratic curve. So it's actually this curve right here. Starts off slow and it speeds up over time. So this one is actually y equals m squared. And then you have cubic. Remember I showed you cubic, which is just y equals x cubed, and this is that curve, but it's a more sharper curve. It takes longer to ramp up the speed. So you have a lot of different types of easing functions. You got this one that's nice elastic. This one, and it's kind of cool. You highlight and you can kind of see where the animations are going. So. And one final thing is that I'm getting the equations from tween.js. So if you want like a full library that has all the easing and every tween type of functionality you want, and you might I'm probably even explain what a tween is. Tween is just an animation loop. It's just a way to animate from point A to point B based on time and different things. This library has like a yo-yo function and things like that. If I go to source, so there's quite a bit to this library. It's not a big library, but it has quite a bit of functionality that you can piece through. I personally just came for the easing functions. Like I said, quadratic, that's x squared, and then you got cubic, that's x cubed. Those are the more simpler ones of easing. So yeah, so we're going to be doing easing and I'm going to animate. So I have other things I can show you, but I'd rather start doing some code. So one of the first things we're going to build is a very simple new quad function or object or module. Actually, it's a module because I'm doing JavaScript modules. Now, I want this quad to be able to build a quad that's standing up or sitting down. For right now, I'm building a quad that's standing up. Later on in my add functionality, where it kind of flips it, where it's sitting down. Now, what this way works is that I'm going to bring in the minimum and maximum bounds of our quad. So I'm going to define it by the smallest point to the maximum point, kind of like our bounding boxes we did for array intersections. So basically the same idea, the mix and the min and max. So this way allows me to define a quad that might make animations easier, and that's the reason why I did this, because I do have an object called quad1unit. This one allows me to choose whatever size I need it to be. It could be 2 units big, 1.5 units, and I get to choose where its origin is. Yeah, this one's just a small, simple one. Let me open this back up. So yeah, this is just very simple. I broke it down to 2 parts because sometimes I just want the data, and other times I want the whole rendering object set up for me. So one or the other. And like I said, the first example we're going to do is like I build the quad from origin. Instead of the origin being at the center of our quad, it's going to be the corner. So this allows us to do some fun animations a lot easier just by placing the quad in a different part of the coordinate system, or different parts of the thing. And then we have our tween module. In our tween module, I took those equations, and I laid them out differently than they are. I did it this way, all static functions in an easing class, because I wanted to make a very quick and easy way to access them. Because even though there's the tween library, I'm not using the tween library. I'm just using their equations. I'd rather write my own tween library. I've been doing it since 2002. So it's like it's an animation loop. It's very simple to do. And on top of that, I want all this stuff to be easily portable, because I want to do a desktop version or a mobile version of Fungi at some point. Definitely a desktop version. So I can't depend too much on external libraries, because sometimes they have too much code. And if I want to bring this into the desktop world, I can't bring JavaScript functions unless I port everything over. So our math libraries comes from GL-math matrix. That's why I actually create all these functions or these modules ourselves, because I need these things to be portable. So I need to be able to write it myself, or at least look at this, at least have the right amount of code that I need to actually get Fungi working, not have all this extra stuff that I'm not probably using. That's the thing with libraries. They try to be a little bit of everything for everybody, and sometimes you only need a small slice of that functionality. So, and here's our tween class. Our tween class is actually very small, hence why I said I didn't want the whole library, because I wanted to keep it nice and easy, something I can very easily port over to C++ or Java. So yeah, these are just all the equations. Down here you have the tween class. We set up our how long in seconds, or actually in milliseconds, we want the animation to go. We put in the easing name, and we put it as a string, so this way I can access it this way, very quick and easy. The tween function uses it as as a reference. You have to pass in some function reference. Here I just pass in a string, and to me it's easier. API wise, it's easier. It's more error prone, because if you type the name wrong, you get an error. But I just want to make the API simpler instead of making it longer, like you have to type out more. So that's why I'm going in this kind of route, make everything static and make everything accessible through an index function. Indexing by using that array brackets. Then we give it a function pointer to do updates. So every time we update, we're gonna do all the math, and then we're gonna pass the resulting values to the update function. So this way we can customize how we want to tween. So I think the tween.js library does something very similar. It does it automatically, and it has, or you can do an update function. This one I don't do it automatically. I just have an update function because the library is always in flux, so I'd rather just write an update function for me personally. It's just easier. Sometimes I just don't want to update something so simple. Sometimes it's more complicated than just changing rotation or something. And that's really, like I said, there's really not much to it. It's really kind of just our render loop. I just end up copying and pasting our render loop and doing something similar. You know, I get the date time. I divide the time by the maximum time, so this way I can get a normalized value. If it's greater than or less than the range that we want, doing 0 and 1. And then we use our ease function, and we pass in the value that's between 0 and 1, and we get a new value back out, which is our ease. And our update, we pass in the normalized time, which is you know, the lifespan that we've been using in shaders. So between 0 and 1, the whole lifetime. And then we pass in the value. So this way we get both. Sometimes I might need the value of time, like, or the lifetime value, the normal time and normalized, I guess I should say it. And if the normalized time is greater than or equal to 1, we just shut it off. This one doesn't have looping built in. This thing just runs once, and that's it. Very easy to do. If I wanted to do a looping, I would probably say if norm equals 1, I'll probably do something that kind of just restarts it. So this way it just keeps going back to 0. And I guess I'll do like mstart gets performance now. So this way the next time the loop starts, it starts from 0 again. So that's if I want to do an infinite loop. Like I said, it's probably another 4 or 5 lines of code to really just make an infinite loop. But I'll put it in when I need it. Like I said, I want this to be as lean and only has what we need. And I just have to have some constants. So when it's done, I want to be able to know when I'm done animating. So now if I go to the test code, we're just bringing in some of our stuff. We're bringing in our tween. We don't need the easing. We'll leave the easing out because easing is an exportable class. I built it this way too because I want to be able. Sometimes I want to use easing without tween. Maybe I'm going to do something else with it. So I made it the module library this way, so you can just import what you need. If you want tween, you get tween. If you need easing, just get easing, or you get both if you need to use both for some reason. So, and then we have our quad. Some of the stuff is whatever. It's really we're going to be using Bendy later, but for right now we're going to have Bendy commented out. So the first thing is we're going to do our new quad, and we're going to build it from 0, 0 to 2, 2. So it's going to be 2 units big, but the origin is going to the corner, this bottom left corner. Yeah, the bottom left corner will be at origin. So this way we can kind of give it a kind of a pop up animation. So this instead of like if I make it from the center, I can make it spring from the center. But for something I want to do with Bendy, I needed to pop out from the corner. So we can actually play around with that if you want. So you know, we create the quad, we set true, false, and then we say I want it 2 seconds long because this is in milliseconds. Bounce in, that's the animation I want to use. I get the norm, I get the ease, and all I got to do is set our quad's scale to the exact same easing value. So, and that's really all to it. And I just do an update, which oh yeah, that's right. And then that's right, you have to do an update. For every loop, I do an update, which kind of continues the animation forward. And that's really all to it. So if I come here, click refresh, there you go. That's it. Just one quick animation. It's nice. It's using that bounce in. So if I want to, you can do something else. Let's say if I go into here, I just pick a function name. I don't know, elastic in out. Why not? Click say. If we do this, click refresh. It kind of springs a little bit and springs up. But you see how everything kind of just pops out from origin, like from that corner, because that's kind of the effect I'm going. But if you wanted to, you can do something like this. If you want to be come out from the center. So as you know, there you go, boom, 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 right from the center. So that's kind of why I built the quad function this way. So you can kind of control where origin is. So this when you do like animations with rotation or scale, you can kind of make things look differently just based on where you want to put origin. So now that we got, that's really just, that's all what tweening and easing is. That's all it really is. It's just that little bit of animation loop, and you use that those easing functions. Now we're going to have some fun. Now we're going to create, if you remember in our previous video, we had Bendy, and we had like a little cube that's kind of like our drone that circles around it, and every time it's within the line of sight, Bendy animated because he was panicking. So we're going to make him more animated, more cartoony. So one of my favorite comic book artists is Adam Warren, and I love how he draws talking bubbles. Online, he has his first 3 volumes of his Empowered series as a webcomic. So I love how he draws the bubbles. Like they're very animated. Like everything he does, text and bubbles, everything's hand drawn. There's no computer stuff really done to his artwork. So it's really cool. You get really interesting things when it comes to his art. I actually want to make a game similar to this style, like black and white with a lot of these, just textures, like these pencil textures. I would love to make a game stylized in his comic book style. So I went through the 3 volumes online and photoshopped my own atlas. So I had to do a bunch of Photoshop stuff to make it kind of usable. So it's a little bubbly, but I had to get rid of a lot of the sketchiness and things like that. But yeah, I got 4 bubbles and 8 emotes. Sometimes emotes of some type. The only ones that were not in this comic book were this one, and that one. The rest come from the Empowered comic book, including these 3. So we're going to use this atlas that I created. This is similar to the Fire atlas that we used before. This is 5x12, and it's every cell is about 64 pixels wide. So we get to use the exact same math as before. I have 2 Photoshop files. I have the atlas at like 1024, and then I have each one of these as huge in a PDF file at 512 each. So for my Patreons, I will be posting the PDFs, or not PDFs, PSDs to the Patreon for free. Anyone else who doesn't, they can take this atlas and use for free too. I really don't care. Like I said, this comes from Adam Warren. Please don't sue me. You are an awesome artist. I'm a biggest fan ever. But that's why I want to do this. I want to use your stuff is awesome. Like I love that bubble. And some of these are just look awesome. They're just very cartoony. They're just very animated, and that's what I want. I want Bendy to be very animated. And I love anime. On top of that, I like watching cartoons with my kids. And with my wife. So we're going to animate this. We're gonna have these things pop up. That's why I have the quads set in corners. And now we're gonna be double dipping on our textures. We're gonna calculate 2 different cells, and then we're gonna blend them together. So we can put this icon inside there. We can put that icon inside there, and it's gonna be random. We don't know what Bendy's gonna react every time he sees the drone. So there you go. So we're going to comment out this guy, our little test thing. Then we got Bendy, and we're using a class called Emote because it's something I created. New. Now go down here. We're going to comment out this emote update, and we're going to put that one up there. Okay, so this is our box being moved around. This is our box rotating to always face Bendy, and all the code for animating Bendy I kind of took out and threw in functions. Same thing for here, like prepare Bendy. It was a lot of code to do that, so I just throw them in functions so they don't kind of, they're thrown at the end. This is all the same stuff from the previous video, like download using the GLTF thing and creating the armature and getting all the bones. I think I did reset. I changed the animation a little bit. He no longer moves his legs around. He does something else. We'll see. Here's what I changed, and I'm not going to say what he's going to do. But if you can read that line of code, you can probably surmise what Bendy is going to do instead of moving his legs. Okay, so that's Bendy. So let's look at our EmoteFunc class that I created just for this. It extends a renderable, and it creates its own quad. That's why I have it set up so I can either create a renderable or I just get data. So I want to get data in this instance. I just want to get data, and I set the size to be just 1 unit, and with the coordinates origin. So it sets up our regular video, sets up our options. Here I can set our maximum scale. I'm going to animate the scale, so I'm going to scale between 0 and 0.4. And this tells me which atlas index I'm trying to use. So to start off with, I'm going to use index 0 and index 5. So if I were to go here, index 0 is this one. So that's 0, 1, 2, 3, 4, 5. So I'll be blending these two together. Excuse me. And then I'm setting up our tween. So I want this to run less than half a second. I'm going to do an elastic out. And if I'm opening, I'm going to be using the ease value. If I'm going backwards, I'm going to invert the easing functions. So if I'm closing it, I'm going to do the animation differently on update. And I'm using this anonymous function instead of did I do it differently up here? Yeah, here I use like functions. Just it's also anonymous function, but different way of doing it, and it kind of gives you something. In case you don't do JavaScript that much, this is just a regular anonymous function. This is also an anonymous function when you do it in this form. The only difference is that when you create it this way, this variable sticks to this emote, so it kind of ends up becoming like an actual property of emote. So this way I can use this reference inside it without doing something like if I use function, I have to do something like this: var o this equals this, and then do function, and then I have to do this, because you have to create a reference that gets bound by that function definition. But if you're using it this way, you don't need to do that. So that's why you'll see it done differently, because I'm using this reference stays when it creates this function for me. So that's just a JavaScript thing. So yeah, so if I'm closing, I'm going in backwards. If I'm opening, I'm going forwards. And I just multiply by the maximum scale, and you set the scale. So show function, I save the state of open. I set the state for visible, because the visible state allows me to not render at all. So I kind of just make sure to set it, because if it's not on, I don't want the render loop to even bother trying to render it. I set the easing function, elastic out and start. So it starts the animate. It gets it ready to animate. So every render loop, when I do the ease update, or actually emote update, it it just moves the animation forward. And then when you show, we're gonna just randomly pick the cells in our atlas. So between 0 and 4, is for the bubbles and starting at 4 and then moving up to 8. You know, so it's like 4, 5, 6, 7, 8, 9, 10, 11, 12. So between 4 and 12, that's the value that's going to be in that thing. I'm sorry. I'm like, my dry is super dry. I need some tea or something. My voice probably sounds like crap today too. Sorry. So that's show. Hide sets is open to false, sets the easing to a different easing. So I want to do a different easing when I'm animating out. And then have an update function, which so that's the function that's called for every render loop. So it checks to see if it's active. It does the tween update. If the tween update equals true, equals complete. I'm sorry. And, you know, whatever, sets everything to false. And then on draw, I override the renderable draw. So I set the atlas to my shader, and I just use the renderable's draw function. So I just do the shader update and then draw. And the shader I'm using is called Emote. So that's all really to that. So if I'm in Emote, it's a lot. It's similar to the Blackfire one that we're using. It's same thing. There's not really much. The only difference I have a vec2 in here for grid position because I'm passing in 2 values and once, and I'm using a vec2 to do it. UV back, UV 4. So I'm going to calculate 2 different UV coordinates that I'm going to pass to the fragment shader. This stuff is the same thing from the other shader. So this we can calculate the different the positions for our UV positions for our atlas. So I don't know. This stuff was here before. So I have UV back. That chooses the bubble, uses ST. I can probably use UV. I can use XY. It doesn't matter. These are all vec2 parameters or properties. And so that gives me the UV. So like I said, instead of calculating just one UV, I'm actually creating 2 UVs. That's something I haven't done before, and it was fun to experiment with. This one is just our usual billboarding equation. And then there's our fragment shader. And our fragment shader, you know, we bring in our 2 UVs. So we grab 1 pixel for the back, we grab the second pixel, and then we kind of just blend. We kind of just blend the pixel together. So we take the back. I played around with this. I was messing around with this. So the back color times the alpha of the front, because I'm trying to overlay the icon on top of the bubble. So I need to make the back icon more dim, but I'm doing invertly. So if the front pixel have an alpha of 1, so 1 minus 1 will make 0. So 0 times this equals 0. So that makes like a black color, I guess, right? Yeah, it makes a black color. So I'm basically using the icons as like a mask. Basically, I'm just wherever this, you know, that's what I'm just using as a mask, really. So the first icon is an actual pixel thing, and pixel image, the texture I'm using, and then the second one I'm actually using as a mask. I'm just kind of just blending it all together that way. And I just take the alpha of both and just add them together as the alpha state. So that's really how this all goes. So if I go here, refresh, still not there. I didn't save here. Refresh. There we go. So every time the drone Bendy now bounces. He jumps up and down. That's what that line of code is set to see if you can interpret what I'm doing. And every time the drone, the little bubble appears near his head. And I have a billboard so you can see it all over. I don't have the skeleton bounce because I'm not animating the skeleton like its position. I'm just animating the actual mesh. That's why the skeleton doesn't move, because I'm not changing the skeleton's actual render position. So yeah, that's it. That's tweening. Oh boy. So that's tweening and easing. So the bubbles comes in with a nice little spring, and it's kind of just slides right out. Do it one more time. Let's see what we get. Boing. We got the teardrop. He's upset. He's worried. He's concerned. He's I don't know. I forgot what there's a bunch of emotions a teardrop can be. It can be he's worried, he's concerned, he's embarrassed. That one's musical. He's musical at that point. And this one more time, just for fun. He's happy, he's excited. So I love it that the bubbles and the icons or the emote icons are random. You just don't know what's gonna pop up. And he's like excited, he's bouncing, so it's kinda neat. He's like, yeah, he's on TV. Woot. The same icon, different bubble. So again, that's it. That's easing tweening. They add a lot of extra functionality to animating. You can make things just appear smoother. It's just a curve. It's all it is just a bunch of curves. Let's see, where is that? It's a bunch of curves. Oh, there's one more easing function I found this early this morning. I totally forgot to actually. Let me see if I can find it. Gain and gain. I forgot what it's called. Gain easing. I wish I said. Damn it! I forgot what it was. Let's see. Can I look over here? Because I have another computer over here. This is bad. I'm sorry. Bias and gain. Bias and visualizer. Visualizer. There we are. Demo Fox. This is another easing thing I found this morning that I should really wanted to mention. Very simple equations. And it's the same thing as easing, where the easing functions are they are what you get. That's it. You can't really change the curves or anything. These are what they are. The gain and bias equations allows you to actually change it. So if I'm using, let's say, the bias function, right now it's a smooth curve, and it kind of shows you an example of what these easing functions can do if you play with them. But you can actually change the curve. So this way you can make black more toward that corner. You can have the animation act a little bit differently, or you can switch the curve over that way. And like I said, easing functions can be used for a lot of things. You can use it for gradients. You can use it for animating movement, animating colors. Anytime you want to go from point A to point B, and you don't want to do it in a linear way, you can use some kind of easing function equation. So yeah, that's bias. So bias gives you that nice curve, which is like kind of like a quadratic or a parabolic that you can go back and forth. And then you have gain, which kind of creates that little S shape. So you can kind of really customize how things. You can like, it's kind of cool how you can do it with animations. I kind of like this. Where you come in, it stops for a second and then goes. That's kind of neat. You can do kind of some cool functionality with that. Let's see. So it's kind of cool how you can control gradients. You can do that. You can create that nice little bevel at the end, like not bevel, like that little mix between black and red, just by switching it. So yeah, so this is another one. The only problem is it doesn't mesh well with the other easing functions, because the other easing functions you pass in time and that's it. Bias and gain, you have to pass in an extra value so you can customize the curve. So at some point I might update my mini tween library to kind of integrate gain and bias into it. But like I said, I found it this morning. I thought it was really neat. It's something you guys might want to play with, because it's really cool, because you can customize. You can end up you can kind of animate the actual gain and bias you put in there too. So you don't have to set the value and just call it a day. You can actually really make it kind of interesting, where you can kind of customize it in real time based on whatever conditions you come up with. You can do this and then switch it around. You can make it random. Like every time the thing comes in, you can change the actual parameter for gain, so it animates slightly differently every time that it appears on the screen. Who knows? Like I said, it's up to whatever ideas you can come up with. Like I said, if you need to get to point A to point B, you got Robert Penner's equations. You got Ken Perlin's gain and bias. Or I'm sorry. It's Christopher Schlick who created these functions. So those are his functionality. So yeah, so easing and tweening, that's everything we got. If you guys want the high quality versions for Photoshop that you want to then incorporate into your own projects, just $1 on Patreon, you got it. If not, like I said, this 5x12 free to use. You go ahead, guys, use it. It's really cool. You can add in more icons if you want. You can fit in 4 more icons. You can change it. You can swap out some icons you don't like and put some in here. Just make sure that they're kind of centered very well inside these bubbles. This book is really old, but if you really want to buy it, go for it. But it's Macromedia. It's not useful anymore. Most of it I don't think is useful anymore. So, but it's great. It was a cool book back in the day when I bought it. So yeah, you got the Tween.js file if you want. That's good. And yeah, this is a great site. I'm gonna put all these links in the description so you guys can whatever. Oh yeah, that's right. One last thing. I have a Twitter account now. A viewer asked about if I had a Twitter account, and I said I kind of did, but I had it off for a long time, so I kind of reactivated it, and now we're back. Oh, I should have just checked my Twitter. I forgot. I probably posted it this morning on my Twitter account about the bias and gain. An article that actually talks about it, not the actual visualizer. So yeah, I have a Twitter account for Sketchpunk Labs. If you guys want to follow it, since he suggested it, I'm probably going to use it to, update when I have a new video. When I find resources online related to game development, articles, equations, sample codes. If I find it that's really cool, I'll probably just post it on Twitter. So it's so if you're into game development, maybe this might be a good Twitter to follow, because I'm really gonna do that. This is something I was working on last night. This could be for the next lesson. So you'll see progress for the next lesson. I guess through Twitter I can do that. It might be fun. So yeah, Sketchpunk Labs Twitter. So yeah, just again, like and subscribe. You have any comments, go for it. Have any questions, go for it. I always try to respond. So yeah, I guess I'll see you guys in the next lesson, and I hope you're having fun animating.